All right. Hello, everyone. My name is Makoto Air, co-founder and CEO of Homeostasis. We transform atmospheric CO2 into critical materials for our electrified world. So, talking about the climate crisis, this is something we're all fairly familiar with at this point. In order to meet IPCC objectives to avoid the 2 degrees Celsius anomaly, we need to pull 10 billion tons of CO2 out of the atmosphere every year by 2050. Now, to put that number in perspective, if you were to take all of the crude oil and natural gas that the world accesses each year and put that in a bucket, that bucket is 7 billion tons. So we have 2.5 decades to scale this massive, massive industry. We have a lot to do. Now, at the same time, the battery market is experiencing some critical carbon supply problems. Lithium-ion batteries are 25% graphite by mass, and graphite is just crystalline carbon. There is an 85% shortage of graphite, according to the IMF. Now, what's more, north of 90% of global production is based in China, and they recently placed some pretty severe export restrictions in retaliation to us doing some stuff with semiconductors. So the trade war is expanding. That is impacting our ability to produce batteries. Now, finally, synthetic graphite, which is really the good stuff, is made from fossil fuels, results in high emissions, and is just too expensive for battery manufacturers. It comes in at $10,000 per ton. So at Homeostasis, we're working to solve both problems at the same time by harnessing the graphite that we need from the sky. So our novel, innovative process pulls CO2 from the atmosphere and converts it into graphite. Since we're mining the skies, we have virtually limitless supply. We could produce this anywhere on Earth, and because we're electrifying the entire process, we can actually do this at half the current production cost. So it's a win-win-win there. Now, what you're seeing here is actual carbon, actual graphite that we've synthesized from the air using our mineralization and electrolysis tech stack. So we've built over 24 hardware variants. We've run over 75 tests across them. We build, test, and iterate rapidly, and that's exactly what the industry needs today. So how do we do this? Well, we remove CO2 from the atmosphere using water with salts, metal oxides dissolved in them, and this forms carbonates. In this case, we're showing barium carbonate. We pull that carbonate slurry that's containing the CO2 out of solution. We dry it out, we then melt it, and then we run electricity through that molten solution, producing carbon, which is our final product, oxygen, which is a waste product, and the salts that we use for additional CO2 removal. We rehydrate those salts and close the cycle. So it's a cyclic, two-step cyclic system. So now let's look at this tech at deployment scale. Large battery manufacturers like Panasonic will require that we produce roughly 10,000 tons of this material every year. So a homeostasis plant at this scale would be about 50% larger than your average Costco, about 200,000 square feet. Now, selling at half the market price, we'd be producing $50 million of revenue every year. The capex for this facility would be about $110 million, and the opex at roughly 25. So we would be able to break even on this project after about 4.5 years of operation. Now, all of this is without considering the effects of the IRA, right? So we've got 45X and 45X and 45Q tax credits that we qualify for here, as well as the sale of voluntary carbon credits. So the story can really only improve from here. Now, using a bottoms-up approach, the global market is growing into a $81 billion monster by 2030, with North America accounting for $12.4 billion of that market. Our customers are battery cell manufacturers with operations in North America, and there are 60 known projects that fit this criteria. Our objective is to have 10 full-size projects up and running by 2030, giving us a sum of $500 million. So there's clearly so much for us to grow into here, right? This is just the beginning. Now, conversations with customers have shown us that we can deliver what they need at a competitive advantage, right? So by, again, mining the skies for synthetic graphite, we're able to deliver a quality, cost-effective product at a reliability and sustainability profile that outpaces the competition. Now, my team and I come from worlds of doing very, very difficult things. We've got aerospace engineering, material science, climate policy all under our belts. We know how to tackle deep tech, and we have access to world-class engineers for when we scale. With DOE funding, we have started producing some test battery cells. We're really excited about this. This is to test the performance of our material, and we've been doing this at the Washington Clean Energy Test Beds over at the University of Washington. Now, these results will lead to LOIs, higher fidelity cells, so pouch cell tests, and unlock material transfer agreements with prospective customers. Now, all of this is in the name of getting to that first pilot. We plan to have this built and operated before the end of 2025. So with that, I would love to connect. We're looking for partners primarily in the battery cell manufacturing space, and for investors who are passionate about enacting real-world change. I want to emphasize here, this is true disruption, right? We're taking the thing that is killing us and turning it into a critical part of the solution. This is absolutely revolutionary, and we hope you join us. Thank you.